Pictured here you have two iPhones, and let's call them slightly different states of repair. I want to ask the blindingly obviously question, which one is easier to deal with? So today we're going to be looking at simplifying complex equations. And to do this, we're going to simplify each side of an equation. That's going to turn it into a two-step equation, and then we're going to solve that two-step equation. So looking at our iPhones, it's pretty obvious that the easier one to deal with is the one on the bottom. The one on the top, it looks extremely complex. There's lots of stuff going on because we've taken that phone and we've literally taken it apart. Whereas the bottom one is all one cohesive piece, nice and easy to use and a lot more functional. But what we're going to see with equations is sometimes there is a simply required. We want our equations to be like the iPhone at the bottom, but sometimes they come to us looking like the one at the top. So what we're going to do is we're going to look at how to fix that. And it turns out that a whole bunch of mathematics, some might argue that most of mathematics, is taking problems that you don't know how to solve and turning them into problems that you do know how to solve. The problem that we know how to solve is a two-step equation. So what we're going to do is take these complex equations and turn them into those two-step equations that we know how to deal with. And the technique that we're going to start with is called simplification. And it's the simplification that you already know and love. We have two techniques for simplifying. We can use the distributive property, or we can combine like terms. An equation is really just two expressions with an equal sign in between them. And if you're remembering this properly, the distributive property and combining like terms can only be used on an expression, not an equation, or an equation taken all together, rather. So I can take the two expressions, the one on the left side of the equal sign, the one on the right side of the equal sign, and what I can do is I can simplify both of those. And sometimes, not always, but sometimes when I simplify, I'm going to end up with a two-step equation, which I then know how to solve. However, the order we do this in matters. Always do the distributive property first and then combine like terms. You can, if you combine like terms first and then do the distributive property, odds are good that you're going to have to combine like terms again. So you've just made the problem longer for yourself. So use the distributive property first and be aware that neither one of these, the distributive property or combining like terms, works across an equal sign. You only do that to one side of an equation, pretending the other side doesn't exist. Once you're done there, look at the other side of the equation, simplify that side, but never ever cross the equal sign. So now that we've heard some of that, let's take a look at some practice. So for our first example, we've got 3 times quantity x plus 1 equals 18. And this is just a distributive property problem. So what I'm going to do is distribute that 3 throughout. So I'm going to take 3 times x. I'm going to take 3 times positive 1. And all of that is equal to 18. Well, 3 times x is 3x. 3 times 1 is positive 3. So I write plus 3 equals 18. And now, lo and behold, I have a two-step equation. I undo any addition or subtraction first, leaving me with 3x equals 15. Now I undo any multiplication or division. Here I've got multiplication. The inverse of that would be division. And I find that x is equal to 5. And that would be my solution. And where I'm asked to solve the equation, that means find the solution. As always, I can check and verify that this is my solution. Replace x with 5. 5 plus 1 is 6. 6 times 3 is indeed 18. For the next problem, it's a bit more complex in the sense that I have a whole bunch going on the left side of the equation. But if you take a close look at it, it's not so bad. Let's start with this first term. There's no distributive property here. I don't see any parentheses going on, so I don't have to worry about that. So we check combining like terms. And it turns out that there is a linear term for x right there. Remember, it's linear if it has a variable and the variable does not have an exponent. And I have 5x right there as well. And then if I look at my constants, the ones without variables, there's a constant and there's a constant. So I can combine 2x plus 5x would be 7x. Positive 4 minus 3 would be positive 1 equals 15. Now that I have simplified this side, there's nothing to simplify over here, of course. This is just a two-step equation. Undo the addition or subtraction by subtracting 1. Then I undo the multiplication by dividing by 7. And I find my solution, x equals 2. And as always, I can substitute that back into the original equation to see if I'm right. 2 times 2 is 4, 4 plus 4 is 8, plus 5 times 2, which is 10, so that's 18. 18 minus 3 is, of course, 15. For example 3, we've now moved to combining both the distributive property and combining like terms into the same problem. Notice there is distributive property going on here, so I must do that first. So I'm going to write this as 28 equals negative 3 times y, negative 3 times negative 2. Remember, I'm taking that sign as part of that. And then my minus 7 just hangs out at the end. Negative 3 times y is, of course, negative 3y. Negative 3 times negative 2 is positive 6. Now I've done the distributive property, but if I look on the right-hand side of the equation, I have like terms I can combine. Positive 6 and minus 7 can, of course, be combined. And so I get 28 equals negative 3y minus 1. And so now it's just, again, a two-step equation. Undo any addition or subtraction. So I would get 29 is equal to negative 3y. I need to get the y by itself, so I got to get rid of that negative 3 I'm multiplying by. So I divide by negative 3. And what you'll notice is that if you put that into your calculator, it does come out to be a decimal. You can list that either way. I have no problem with you leaving it as a fraction of 29 over 3, and then that negative sign can just live out front. Or if you want to write that as a decimal and round off to the hundredths place, that would be fine too. So if you wanted to list that as 9.67, that would be appropriate as well. But again, big picture, we distribute, we combine like terms, and then we solve the resulting two-step equation. So here it is, as ugly as this thing can get. We have to distribute twice, then combine like terms, and then solve a two-step equation. So we distribute, there's just a negative sign here. Do you recall what that means? That means we're distributing a negative 1 throughout those parentheses. So I have negative 1 times 2x, negative 1 times negative 27. Here I'm going to distribute a positive 5 throughout, so I have 5 times 4x, and then 5 times negative 6. Now I'm going to put all those together. So I would have negative 2x minus negative times a negative would be a positive, that's plus 27. 5 times 4x would be plus 20x, and then minus 30. Now, there's no more distributive property, so I look to combine like terms. I can combine my x's, they have the same variable, and I can combine my constant terms, who lack a variable entirely. So I would find that 15 equals, well, negative 2x plus 20x is 18x, 27 minus 30 is negative 3, and again, it's a two-step equation from here. Undo any addition or subtraction. That leaves me with 18 equals 18x. Now to undo that multiplication, I'm multiplying 18 times x. I use the inverse operation, which is division. Divide both sides by 18, and I find that x is equal to 1. And just as before, I can substitute in to make sure that that is correct. So to recap all of this, one of the things we want to look at is simplifying both sides of the expression before we do anything else. Simplifying, of course, means distributive property and combining like terms. So for this particular problem, the first thing I want to do is the distributive property. Always start with that. So I would get 3 times 2x. I would get 3 times negative 5 minus 10 equals negative 1. Just comes along for the ride. 3 times 2x is 6x. 3 times negative 5 is negative 15. Minus 10 equals negative 1. Now I can combine like terms. I have 2 constant terms over here. Might as well simplify them into 1. So I get 6x minus 25 equals negative 1. Now it's a 2-step equation. Undo our addition or subtraction first, so undo the subtraction in this case. And I get 6x equals 24. Now to undo the multiplication, I would divide, and I'm left with a final result of x being 4. And of course I can always substitute that back in and check to see if I was correct.